Hi and welcome to the Pertemps Engineering Podcast. Here we meet real-life inventors, builders and problem solvers who are making the world a better place one idea at a time. I'm Kelsie, a senior recruitment consultant at Pertemps, helping brilliant engineers find exciting jobs. Today we are meeting someone truly inspiring. Helen Famodimu, quality assurance engineer from Atlas Copco, is an engineer working on projects that make a real difference. We'll hear how Helen got started, why engineering is so exciting and what a typical day looks like in Helen's world. So Helen, welcome.
Thank you, Kelsie. Nice to meet you.
Nice to meet you. Thank you for coming on. So just tell us a bit about yourself. What type of engineer are you? What do you sort of make or design that we would know?
So I'm what you would call a SHIKI engineer. So it's safety, health, environmental and quality engineer. I deal with the day-to-day safety and health and safety within my company. I also look after the environmental issues within the company. So anything that's got to do with sustainability, and I'm within that purview as well. And I also deal with compliance. So look after the processes within the company, ensure that we've got our processes done quite straight, and also look at customer complaints because a lot of our process improvements comes from customer complaints as well. So that's just a brief overview of what I do.
Brilliant. And why did you want to become a quality assurance engineer? What made you want to get into that sort of specific role?
Ooh, right. So engineering is a broad field, as a typical engineer would say. I kind of found myself in the quality line. I didn't set out outrightly when I was a young girl to become a quality engineer. I set out to become an electrical engineer after my dad, because my dad was he's a retired electrical engineer and he kind of tinkered with the light. I grew up in Nigeria. So as you can imagine, we had what we call frequent load shedding, which meant we were without lights and power for hours, sometimes days. And sometimes, because of the way the distribution in Nigeria is, your neighbors would have power, but you wouldn't. So my dad was always tinkering with that. So I thought, right, I'll go along with his line so I could help alleviate some of that. I did apply to study electrical engineering, but with the way I kind of grew up in the education system, I got assigned to a metallurgical and materials engineer. So I am actually a trained materials and metallurgical engineer. It kind of sounds boring, but what we do is we look at materials, we look at metals, and we just say what is suitable and what isn't suitable for different processes, different industries. I found myself in the quality line with my first actual real engineering job, and I kind of stayed with that for a while. I fell in love, I would say, with quality and looking after processes with quality after a while.
Of course. And I know that you sort of joked around there saying it sounds boring, but I think quality, and especially in that sector, is so important in sort of day to day. And
Yeah, definitely. I mean, if you look at it this way, metallurgical can be what we'll say grassroots engineering, because at the start of each engineering process is you've got to be certain that whatever materials that you would be using. So design engineers, for example, could design everything, but if they don't get the correct materials for the design, it would fail, which is something I see quite a lot in my quality engineering role. Say, for instance, a material is going into oil and gas industry. We've got to ensure that it's not corrosive, because the industry is quite disruptive to metals and materials. So whatever materials or metals that we use in different industry would inform what materials we would recommend, or what materials metallurgical engineers would recommend or would choose in that role. And like I said, as a quality engineer, my job is to ensure that whatever products that we supply to our customers meet the requirements of whatever job that they're doing as well. So it could be boring maybe sometimes, but it could also be fun, because sometimes what you're literally doing is problem solving, trying to find what the root cause of those problem is and trying to ensure that it doesn't happen again, either to that customer or another customer as well.
of course, and I don't think it sounds boring at all. If anything, it sounds very engaging. Your mind will constantly be working, problem solving, as you say, coming up with ideas. I know that you said you sort of test the sort of metals for certain industries. What industries do you focus in?
Right. So initially, like I said, when I kind of went into quality. I initially started my first role in a metal stock holding company. And basically, we get metal from our mills. We sold that into a variety of industries. So I've worked with two steels, and two steels is basically, so for some people who don't know, two steels is basically your bog standard engineering steel. It goes into various industries. So we have people who made knives from our steels. We worked with different industries, so oil and gas. People who made sugar, for example, needed steel. Aeroplanes, so we supplied into the aerospace industry. We also supplied into nuclear industry. So I've worked with all of those specifications, worked with all of those industries to varying degrees. In my current role, we basically supplying mostly into the energy sector. So that could be anything from, when I say oil and gas again, but that could also mean solar, that could also mean wind energy. So solar power, solar towers, wind tunnels and stuff like that. So we also supply all of that into those kind of industries at the moment. Yeah.
Just so many industries in one position.
Yeah. It just shows you how broad engineering is. I mean, some of our tools are being used in mines. So if you can imagine some of the ones that I've had to deal with where they've taken the tools down the mine and used it and then said, well, it's broken before it's broken, or something has happened, or we've supplied this and corrosion, but you didn't ask us for corrosion resistance. So the engineering industries are so wide and varied, and obviously requirements slightly differ with each industry, which is why I enjoy my job, because you're not just dealing with, just nuclear or just energy. It could be any applications out there, and you just kind of get a little bit of knowledge of each industry, which is fun, at least for me.
And you can just tell just for the look on your face and how you speak about it, how the passion behind what you do and why you do what you do. Going back to when you were a bit younger, maybe sort of starting out in secondary school or coming out maybe even primary school, what were your favourite subjects in school?
Maths.
Maths.
I've always loved math. So growing up in a typical Nigerian household, when I was a bit younger, times have changed. But then you were either an engineer, a medical doctor, or a lawyer, maybe an accountant. I didn't like law. It was too boring. Accountant, I could kind of do, but I didn't like the sound and the look of spreadsheets. So that was not for me. I passed sciences, but I hated the smell of anything that had to do with biology. So medicine was obviously not for me.
No.
So engineering it was. But like I also said, I always loved engineering because my dad was always tinkering around the house anyway. So I was like a little shadow going around in engineering, thinking around with him and whatnot. So I always kind of knew it at the back of my mind that I was going to do something technical, something with my hands, something I could get scrubbed in. So it did help that I always loved math. So I did math, physics, chemistry, and I also did further maths as well. So I always just kind of enjoyed it and liked that mood. So all my studies in high school and in primary school was always towards me wanting to be an engineer anyways.
So it sounds to me that sort of important factors growing up to you to go into engineering was mainly your father, sort of growing up with your father, and your love for maths, I suppose, and problem solving with that. Is there anything else that you can sort of think of that made you think, engineering is what I want to do?
Not particularly. Like I said, I always loved, and I think it was always that curiosity of how things were made as well, which is probably good that I didn't end up as an electrical and engineer, because when I did do some courses about electricity and electrical, I didn't as much love it, but I loved the fact that you could look at a lump of clay and make that into something really useful. And, how the processing of materials went from raw materials to end use was just fascinating for me by the time I was leaving university. Which is, I don't know. Yes, my dad was the initial spark, but I personally just loved the innovation that kind of went hand in hand with engineering, I could say.
Brilliant. And sort of looking back to sort of your time through secondary school, maybe the transition into university, were there any challenges you found sort of going back to being more of a female in the engineering sector? Were there any challenges that you found sort of while studying, going through that process that you found being a female sort of didn't go in your advantage?
Right, yes. So initially, when I finished my high school, I didn't go straight into engineering. I got initially admitted for physics. So I went into there and sort of got there, and I didn't like because I went to another university. And when I was there, one of the lecturers just said to me, yeah, I know you're not going to last in here. Females rarely last in physics. And I know you don't want to study physics anyway. It didn't really give me that support that I felt I needed for a 16, 17-year-old girl going into university and I think where I was only maybe two females in the physics department then. And because I didn't get that support, I felt really lost. So I didn't do as well. Luckily, I redid the equivalent of what A levels would be, and I got into Federal University of Technology, Akure, FUTAS. I then got admitted for metallurgical and materials engineering. And there were only three people in my class that were females. It was a 55 number of people in the class, but only three of us were females. And I was the youngest female as well. It was a bit daunting, and everyone just put me up as the class rep as well for like the first couple of years. I'm like, why? They said, well, because you've got this aura of wanting to make people feel comfortable. I said, well, that's because I want to feel comfortable. But I was the class rep for a couple of years after that. And I said, at this point in time, I'm not doing. So there were times where it was difficult trying to get your voice heard. And as with most engineering courses, for the first couple of years, at least in my school, you're in a class filled with other engineering students. So they put all of you in class A doing engineering math. It would be engineering math for your department and like three other departments as well. In the midst of all of that, it was obvious that I was one of the youngest, one of the few females that were there. And sometimes it's really hard to find your feet and really hard to find a focus. So you're talking about 250 students within a class. And, trying to get the attention of a teacher in a class could be a bit iffy. You don't want to be singled out. And because you're a female in an engineering field, sometimes you feel you have to prove your worth of being in a male-only environment. So you have to know more than them. You have to show that you're confident so that I deserve to be here. And I got to my third year. It's a 5-year course in Nigeria. I got to my third year and I realized that actually I didn't have to prove myself to anyone other than me. And I was always afraid to ask for help prior to that because I felt if you choose to go into a male field, you have to show them that you deserve to be there. So I always never really asked for help until I realized I was failing and there was no one else to blame but me because I was too proud I don't want to use the word shy or just maybe not confident, maybe like it's a bit of like an imposter syndrome that I didn't deserve to be there. And then realized I wasn't doing myself any favors by not asking for help. So I had to build that courage up and look at some of my colleagues, some of my classmates and said, really, I'm holding my hands up here. If you don't help me, I am going to flunk out and I can't allow myself to flunk out. That's kind of been the driving force now since that time, since realizing that was a major issue, major hurdle. I've just said to myself, the maximum anyone can tell you is no. And the no actually is not about me. It's about them. If they can't afford to lend a helping hand to someone who is failing, then it's about them. It's not about me. That I'm failing or that I do not understand concept of some things, but I'm willing to ask for help means that I want to succeed. And that's kind of what I've taken away from that point in time. And I tell my younger ones, my siblings and my nieces now that the maximum anyone can tell you is no. No has never killed anyone really so far that I know of. So I'm always going to ask for help from that time. And that's really helped because my orientation just kind of changed at that point in time. And it just made me so much a better I would say engineer, that whenever I needed any resources, whenever I needed anything, I'll just hold my hands up. I don't understand it, so maybe you can explain it for me. And that's always worked well, especially in my line of jobs. I'm just going to bring that back into my line of job now, especially as a quality engineer. If someone says, well, this is it, I'm just, well, I'm going to, I don't understand this. So maybe if you break it down for me, I might be able to find a way that we can both resolve issues. But if I don't understand it, I can't help. And that's kind of what I've taken away from that period of my life. Thank you.
Brilliant. No, that's brilliant. And I think from what you've just sort of explained, you did experience quite a lot of sort of backlash and maybe just feeling a bit more maybe singled out being a female, growing up in the education system especially, and you've got a lot of coping mechanisms sort of telling yourself, what's the harm in being told no and not being worried to actually ask for help. Is there anything else that you can think of at the top of your head that's helped you through that process of going through that backlash and the struggles of being a female?
To be honest, I don't think the backlash was from the people around me. I think it was more of me being, I put a lot of pressure on myself. And I think for we as females, especially, I'm not sure about other women, but other females in engineering tend to feel that a lot because, like I said, we put ourselves in the pressure because we think sometimes engineering is a male-oriented field. And because of that, sometimes we feel we don't deserve to be there. And that kind of puts us under pressure. So one of the other things I've done in recent times was also I think I first heard of the term about 6 years ago, called Imposter syndrome, where you've got all the qualifications in the world, but you still feel you don't deserve those qualifications, that the qualifications were just a fluke. But in reality, it's not. It's you working hard to get those qualifications and you working hard to achieve those goals. And I think a lot of times that was kind of what was going on, and just not being able to put a word or a name to those feelings didn't help. One of the other things that kind of helped me is because I've got a large and supportive family. And I tell you, that works wonders. One of the things that a large and supportive family does is it just gives you that extra bit of cushion to fall on. I remember while I was studying for my PhD, when I finished my bachelor's in Nigeria, I came to the UK for my master's, and then I got offered a PhD placement on scholarship at the University of Wolverhampton. And I started my PhD chronological wise. I got married October 1st. I started my PhD October 5th. And in December of the same year, I realized I was pregnant with my first child. I was on student visa and I needed to work 20 hours and I had a small baby and with a PhD, which was it's more or less a self-directed learning in the UK. So it was a lot of pressure. And I think it was 18 months into my PhD, I ran crying to one of my supervisors and to my husband, I said, I'm going to drop out. I can't do this anymore. I feel like I'm losing my mind. I don't know how I'm going to cope. I'd done some research, didn't feel like it was going anywhere, didn't feel like there was any meaning to it. And I was just fed up and I was crying. I don't want to use the word depressed, but it was quite a dark time. And my husband just said, take a day, take a break, take a cup of tea, just relax. And says, right, tomorrow go meet your supervisor and just explain. So I went to one of my supervisors and just said, I don't know what to do. I don't know where this is going. I'm just confused. So he sent me away and said, don't worry, I'm going to try and sort this out. So he and the other supervisor sat down, kind of devised a plan of action for me. And I went back to him the next day and I said, right, this is kind of where we want the PhD to go. Do you think you can achieve it? And at that point in time, I think because my husband had been calm with me, I think throughout that day, throughout the coming days, he just made sure I didn't have to worry too much. It took the baby mostly off me at that point. She said, just do yourself, if you need to go anywhere, if you need to calm yourself down, just do that. And I went back to my supervisor and said, well, I'll try. I remember calling my mom as well back then and say, Mom, I think I'm going to drop out. And she's like, before you do that, because I know you really give up on things, I want you to think about how long it's taken you to get to this place. And, just think about your journey and see what in your journey would make you think you can drop out. And she didn't say that to be mean. She said that because she also realized she knew me and she knew that I wasn't a quitter, so to say, and I probably would have regretted quitting at that point in time. So she said words that she knew would challenge me to look at my journey and also look out a way to motivate myself. So a combination of having my immediate family and my husband and my mom, who was back in Nigeria at that point, and supervisors really helped. And I just say to them, and I remember about a month later, I was back on track. And a couple of years later, I was done. And said to them, and I remember going to my supervisor at that time and saying, thank you, Mark, thank you, Chike, because without you both, I wouldn't have been able to continue. And obviously, dedication to my parents and my husband at my graduation. So yeah, sometimes it's good to have your inner motivation, but sometimes also having that extra buffer of the family support is crucial. Since then, any PhD students that I meet, I just tell them straight out, if they're considering PhD, say, have someone that you can call in the middle of the night and rant at or just cry to. Not necessarily because you want to cry, but because life could be quite overwhelming sometimes, and that's the only way you can get through it. The person doesn't need to say anything. The person just needs to be a sounding board for you to just dump on. And yeah, it's fun.
Oh, so to me, it just sounds like that support system that you had around you, not being afraid to speak up when you are struggling and you're finding these challenges. And like you say, you had that support with your supervisor, your husband, your mother. And I just think if you weren't brave enough to speak up and say, look, I'm struggling here, I don't know what to do, you just sometimes need your mum. She'd sort of come back at you and you were like, I can't do this anymore. And she's like, no, you can. And that was because she was sort of pushing to something that she knew you couldn't do. She knew that in 2 years' time or 5 years' time, you may look back and think, why didn't I do those extra few months, or why didn't I just push myself that bit further? And we're all only human, we can't do it ourselves. And I think sometimes we just need that extra push sometimes.
Yes, we do.
So other than that sort of support system that you had around you, sort of thinking about your own passions and your own interests, what did you think that magic was in engineering that made you sort of push through that and think, no, I need to finish this?
Okay, so my PhD then was actually trying to do something novel. It was something that was done, but it was being used. I was using a new technology, and it was fun working with that technology. It was fun trying to get through that technology, which is kind of why they all knew I could do it. I had it in me, and it was something I was super interested in anyway. I was just feeling overwhelmed, I believe, at that time, and a little bit lost. So it was working with new technologies. I've always been curious about new technologies, still am. And any way I can, I would, if I hear something new that catches my interest, any new technology, I dig down, I do my research, I read up all about it, even if it's just trivia questions on quiz time or something. That's the kind of person I am. I've always been inquisitive. So I've always loved to research new things, something new, something that catches my fancy, whether that be a mythology from some ancient folklore or whether that be an engineering innovation. I've always kind of loved that.
Brilliant. Again, going back to sort of like younger girls and thinking about yourself when you were just starting out and thinking about, you really enjoy maths, so I'm going to sort of take this career jump. What would you tell young girls who are curious about engineering or potentially just building new things and just didn't know where to start?
Okay, my journey is my journey. Everyone's journey is different. My story is my story, and I kind of loved engineering from when I was young anyway, so I don't expect everyone to be like me. I remember that when I was speaking to my nieces a few years back and said, why have you never considered engineering? One of them, particularly with the grades to do it, and the response was, I'm not sure what an engineer does. And I had to say, well, an engineer could be anybody, just like I am, and just like any other person there. Looking at your grades, they are not everything. The one thing the UK does really well is the pathway into engineering. You could do your GCSEs. If you've got the grades, go to A levels. If you've got the grades, go to universities to study engineering. However, you could as well go to the college and do engineering diplomas, and still go to university if you want. Alternatively, you could go the apprenticeship route. And a lot of people now are choosing the apprenticeship route into engineering, because what that does is it gives you a hands-on experience, and you could go get apprenticeship level up until university level nowadays anyway. So if you wanted, you could go apprenticeship level 3, level 4, level 5, level 6, and level 7 at the university, so far you get a willing employer. So there are various routes into engineering. Grades are one aspect of it. The most important aspect is having that drive and the interest in it. There's a caveat though. I taught for a couple of years at the college as an engineering lecturer. And one of the main things that I realized as a lecturer was a lot of kids came into college to study engineering thinking they were just going to be stuck in the workshop all day and building up things. Engineering is that. But a lot of engineering is also understanding what we call fundamental concepts. If you don't understand some of the basic concepts in the class, you would injure yourself and you would injure others in the workshop. Or perhaps you could build something well in the workshop and it goes out there and injures someone. So you have to understand the concept. You have to understand how things work together. So be prepared if you're going to go into engineering, whether as a university student or whether in through apprenticeship route. Be prepared for both the practical aspect and what we call the theoretical aspect of it. Be prepared to learn and then to apply that knowledge in the workshop. That's just the baseline. Outside of that, interest trumps everything else.
Definitely. I've got 2 questions here that sort of tie in with each other. First of all, why do you think it's important to have more girls in the engineering sector?
Right. One of the things I did while teaching at the college was also wonder why there were not more girls in engineering. It's a fun subject. And like I've explained, there are so many industries out there that you could go to as an engineer. There is so much awareness. So why aren't there more girls in engineering? You get the chances, you get the opportunities. And if you're dedicated, you can go far in engineering as well. So one of the main things that I did find out was sometimes girls were not encouraged, is the word, to go into engineering. I remember speaking to one of my students. I had taken her from level 2 to level 3 first year. Level 2, she was absolutely brilliant. Level 3 first year, she was just okay. Level 3 second year, kind of like she dropped up. And I remember taking her outside after class one day and said, "What's going on? This is not the person that we kind of saw, and you can do more than this." And she just started crying and said, "I don't know what I'm doing here. I don't feel like I belong." I'm like, "Why?" She said, "Well, I was doing well and I was okay, but then I just kind of lost passion." And I said, "Why?" She said, "I don't know." And it took me for a while and said, "At the end of it, are you interested in engineering?" She said, "I think so." Don't let anyone else get to you. Don't let your friends could be playing and they could be doing whatever it is. But if your interest is in engineering, but just because your friends aren't in the same department as you and they seem to be doing something a bit more fun, doesn't mean that you don't get to do fun things eventually. So I love my engineering friends. I've gone on to build nuclear reactors. One is designing a chemical plant. One is designing bridges and tunnels. One is designing road and pathways with civil engineering. One is on the HS2, working on designing and building and making sure HS2 goes well. So there are so many fun things. One works with Formula One. One works with different industries. So there are so many different and fun industries that you could go with. Some of my colleagues go on wind turbines. How cool is that to be able to go on wind turbines as big and as massive as they are? And I'm afraid of heights, so I can't go on wind turbines. But, building tunnels, building the underground, there are so many things that you could do with engineering. Something as simple as paper towels, something as simple as sugar that you have in your homes. So why not? There are so many pathways that you could go into engineering. So why not? Why box yourself into one job? Engineering, there's so many pathways and so many things you can do. So why not?
Exactly. And I think this just comes back to your point earlier on saying not being afraid to speak out, go into your support system. And also, I think some of it does come to sort of improving people's knowledge of what an engineer actually does. I mean, I specialise in engineering recruitment now, and I have done for 3 years now. But I'll hold my hands up when I was in secondary school and I was thinking about doing my A levels or my BTEC. My sort of knowledge around what engineering actually is was very foggy. And it wasn't until I was actually starting my 20s and I sort of started asking my friends who were going into engineering. I was like, what does an engineer actually do? And it's just sort of one of those I look back at myself and I just think, if I knew that myself like a few years ago, who knows where I'd have ended up. So I just think it's sort of really sort of not glamorising it, but just sort of taking that, what do they do? Or, it's for boys or, it's boring, and just sort of actually realising, well, you can do this and you can actually do all these amazing things. So I think it's sort of improving the knowledge and having people like yourself being a college lecturer and sort of really sort of inspiring people.
Yeah.
What was you going to say, Sarah?
Sorry, I was just going to say that was what kind of came back to me from my nieces and their friends, in that they weren't quite sure what an engineering does, which is why we're trying, and a lot of people have tried to make awareness, and we're realizing as of 8 years ago, the awareness was more around university students and more about apprenticeships, people who were already on the engineering route. But actually, what a lot of people are doing nowadays with outreach is looking at primary school and secondary school students and actually teaching them there, catching their attention then of what engineering is. It's not your regular DT at school. It's a bit more than that. It's looking at practices, looking at things that engineer does. I work with a company called Association for Ethnic and Minority Engineers, which is a non-governmental organization. And that's kind of what we do. We look at engineering throughout its whole pathway, from primary schools where we do making engineering hard. We look at do like big fun fair in London with different schools and different various engineering industries, bring them in and they work on various different things through to university, early careers, and there's that support in there. Just trying to raise awareness of what an engineer does and how we ensure that people actually choose engineering as well.
Exactly. I think there's been such a focus the last few years, maybe people that are already on that journey, that have already expressed an interest, to sort of inspire them a bit further and take that knowledge a bit further. But how do we actually get people to spark that interest? Like you say, your primary school, your secondary school level. And this is something that Pertemps have been looking in the past year now, and we've brought out the primary school book that we were giving out to young girls between the ages of 7 and 9, just really breaking down those job titles and what they do, and you'll see like a hefty job title and it's actually like, no, they build these things. It's actually really interesting, and I just think we just need more focus around that, so younger girls spark that interest and know how to sort of start the journey.
Yeah.
And what would you say to somebody who said engineering is just for boys?
Oh no, I mean, I'm here.
Exactly.
And I've got other female colleagues. I've got female friends. A lot of my female friends, a lot of the people that I work with in AFB are actually female, and all of them are engineers. The person designing chemical plants is a female engineer. The person designing the bridge and tunnels, female engineer. Person designing transport links, female engineer. There is nothing such as a job is just made for men. No, there's nothing like that. We do the best we can wherever we find ourselves, and that's just it. Engineering is fun for both males and female. It doesn't matter your gender, so far you have interest in it and you're willing to work hard. That's it.
So can you share a project that you've worked on that you're especially proud of that we wouldn't realise is in everyday life?
Oh, it was down to customer complaints. You've got to understand some of my customers, most of my customers are large corporations who are building wind vanes in God knows where. And one of the customers came and said, well, we bought this tool for like a couple of months ago and it's all damaged and broken up. And my job was to not just give them replacements. Replacements are easy, but just to also look at what went wrong. And that's my day-to-day job. What went wrong and how can I improve things? And bringing the tool back to my side, it was obviously broken. A little bit of investigations. We've got on site, we've got the assembly production, we've got the machining, we've got the production department, we've got sales, and we've got design. And my job is also to look at all of those aspects. Those are very, like I would say, at least 3 different types of engineering in there. You've got the people who actually assemble and put the tools together. You get the people who machine the parts, and you also get the people who design the part. We all work collaboratively together. And in looking at that, we didn't seem to find anything wrong with that processes. I looked at that and thought, right, the tools were assembled correctly. And I also looked at machining. They were machined correctly, correct to the drawing, and correct to the dimensions and tolerances. I then looked at the design. Design seemed okay. So what could be going wrong? And that's when I and the design engineer then went through our delivery of the metal, putting on my metallurgical art now, because that never goes away, and then realized that actually we'd used a different material than the one we specified on our design. It's different, but the same. So for people who are not aware, we have metals made in the UK, designed for the UK market. Similar metals may be designed in other countries, but they won't give you the exact same because they've changed one small thing, something very small, minute material. And that was the case where they'd used a different country specified grade as an alternative to the UK specified grade. And that small change cost us a lot of money because it meant we had to recall all the components and all the tools that were made from that particular material. Just shows you how something very small could be, could cause a massive issue in the long run. We had to recall all of that and send them new components made from the same material, from the new material. Luckily, no one was injured. There wasn't any safety issues. It just meant it was reviewed. And that also helped me improve our process to say, whatever material that you're going to be using for whatever part, whatever tool, that needs to be reviewed ahead. And because of that, we highlighted something critical within our processes where materials for some components were not checked, and that's now being routinely checked. And that was because of that particular case. It just goes down to, how we improve our processes based on a customer complaint. Something that we think might be actually small could be big on the long run. But I was particularly proud of that.
I think just sort of, like I say, hearing the way you speak about the process through that project just really opens your eyes. I can't actually imagine the amount of job satisfaction you get doing what you do, getting to the bottom of it. You're that person that got to that result and sort of coming up with a process to think, okay, well, this is what happened here. What do we do next time so this doesn't happen again? So I'd imagine there is just constant a lot of job satisfaction doing what you do.
Yes, I was particularly satisfied with that because I had highlighted prior to that the risk, but it was sort of, oh, don't worry, it's not a critical component, so we're not going to worry too much about that. It's something that, and then it happened, and I said, well, remember about 6 months ago when I said this was a risk? And he said, well, yeah, we understand. So it kind of helped that, it'd been brought up before, and now there's that process in place such that we are able to catch some of those errors before it goes out. So if a component is coming in, we have the material certificate ahead, and we're able to review to ensure that they've used the correct material prior to that. And that just stops it from going out. If it's not the correct material, we're not accepting it, we're not using it.
I just think that project alone is probably a small example of why you do what you do is so important.
Yeah.
In your sector and any sector, I suppose, the quality side of any process is so important.
Yeah, and that's one of the things I enjoy about quality. And I don't want to say we're the gatekeepers, but we also help ensure that everyone keeps safe. That's it. Because if things are not done the right way and the right time, and we let bad things escape from companies, then it means that that tool or that product could injure someone in their future. And we don't want that. Our job is to ensure that while we're on site here, everyone's safe. And while our tools are out there, it's safe so that they can use it effectively. How would you feel if you bought something from a company and 2 days after using it, it fails or it's damaged? You wouldn't like that. My job is to ensure that never happens. We give a warranty on our product, and my job is to ensure that our tool lasts the whole warranty period. Touch wood, it tends to most times.
Brilliant. Thank you, Helen.
Thank you so much, Kelsie.
So that's it for today's episode. A big thank you to Helen for joining our Pertemps Engineering podcast and for helping us to inspire the next generation. Your story shows young girls that engineering is excitable and achievable. Thank you all for listening.
Thank you,
And
Kelsie.
thank you,
everyone.
Helen.